Hello and welcome. Today I'm going to talk about the basic exponent rules for how to handle multiplication and division. So in general, if I have the same base, so when I say base, I mean the lower part of the exponent. So I have x squared times x cubed, for example. The way that I multiply these is I add the exponents. So I have x raised to the 2 plus 3, which is x to the 5th. So that's how we multiply things out. Now, the base has to be exactly the same. So if I have x squared times y, well, I'm stuck in the water. I can't add the exponents there because they do not have the same base. There's an x as the first component and the y is the second component. So there's nothing I can do there. This is also true of numbers. These rules work. So if I have, for example, 2 squared times 2 to the 4th, I add the exponents and I get 2 to the 6th power, which you can plug into your calculator and get an actual number for, but it's sometimes easier to write it in the form like this, 2 to the 6th power. And the same here, if I have 2 squared times 3, well, I'm not going to be able to do any adding of exponents because it's not the same thing in the lower portion. So I would just have to multiply this out or leave it as is if you were asked not to multiply them out. The next thing we should do is talk about division. So what happens if I have x cubed divided by x squared? Well, when you have two things being divided by, again, the lower part, the base of my expression here is x. So the lower part is exactly the same. And so when we do it this way, we actually, instead of adding the exponents, we subtract. So we subtract the lower number from the upper number. So x to the 3 minus 2, which will be equal to x to the first. Now, whenever we see something, we just have a 1 as the exponent, our convention is to not write it at all. We don't usually write the ones. So x to the first power, we would write as just x. Now, the last rule, and this doesn't come up as frequently, but sometimes we'll have something like this. We'll have x squared, and that'll be raised to another power. And this does happen on occasion. If you have something raised to another power, then what you need to do is you multiply them. So 2 times 3. So this would be x to the 6th. So here are the three basic rules. We have addition, and that is when we add the exponents when the two components are being added or multiplied by each other. We have subtraction, and then we subtract the exponents when the components are being divided. And then we have multiplication. And that is when we have something raised to an additional power that we multiply the exponents. So let's do a few examples. The first I'll do is 2x times 5xy. Now, whenever we approach these, I like to group everything together. So I'll take all my numbers and I'll put them together, 2 times 5. I'll take my x values and I'll put them together, x times x, and then my y values at the end. So this is what I have, and then I can do my simplification. So 2 times 5 is 10. X times x, because there's an imaginary 1 in the exponent for both of those, 1 plus 1 is 2, so that's x squared. And then there's nothing I can do with the y. He doesn't have anything that's the same base, so it just gets tacked onto the end there. Let's do another example. Let's consider 2x squared times the quantity x plus 3x squared. This is a good one because it requires that we do some distribution. So I need to multiply in this 2x squared to each component. So my first component is going to be 2x squared times x. My second component will be 2x squared times 3x squared. Now you can start to skip steps as you work through this, but for the first time I just like to write everything out. My first component here, the x squared times x, that becomes x cubed. So I end up with 2x to the third power, to the cubed. And then I'm going to multiply my 2 and my 3 in my second component. That gives me 6. And then I need to handle the x squared times x squared. Because they both have an exponent of 2, I add them, and I end up with x to the fourth. Let's do one more. So here's an even more complex distribution problem. 2a squared b times the quantity a squared minus 3b squared. This is a good problem, especially because it uses a and b as the variable, and a lot of students get mixed up whenever they see that. They're very comfortable with x's and y's, but other variables give people palpitations. All right, so once again, I'll do the same thing. I'm going to distribute this whole thing, negative 2a squared b, to both components. So I have negative 2a squared b times a squared minus negative, so that minus is coming here. That's where I'm getting that minus. And then I have negative 2a squared b times 3b squared. So be a little bit careful with the minuses. You don't want to write them down too many times. I'm taking the minus straight down for the subtraction there, but then I keep that negative in front of the negative 2. Then I can go ahead and combine exponents in order to simplify the expression. So here, I don't have any other coefficients. I only have the negative 2, so I have that. The a and terms, I have 2 and 2, so that gets added to be a to the fourth. We're adding them because it's being multiplied. And then the b, I don't have any other b's, so it just gets tacked onto the end. Now, I'm going to do minus, and I'm going to open my parentheses and keep the parentheses here for a second. My coefficients are negative 2 and positive 3. Negative 2 times 3 is negative 6. I only have one a. There's no other a's in here, so I'll just write a squared there. But then I have a b and a b squared. So remembering that there's an imaginary 1 as the coefficient for that first b, 1 plus 2 is 3, so I end up with b cubed. I'm almost done, but I need to handle these two negatives. Two wrongs don't make a right, but two negatives do make a positive. So I end up with negative 2a to the fourth b plus 6a squared b cubed. And that is our final answer. Thank you so much for watching.